Hello everyone, I'm Yuki from the Solana Foundation's External Level Japan. Today I'll be using this demo to walk you through Firedancer. Why? Anatomy, pipeline is here, pipeline, speed, and timeline, right? And Firedancer is Solana's new validator client, and it's live on mainnet right now. In the past, Solana ran on just one type of validator software, Agave. Agave is here. And there was also a client called Jito, but it belongs to the same Agave lineage. Jito is here. That meant if something happens, there is a risk it could affect the entire network. But with the arrival of Firedancer, that risk is now distributed. Firedancer is here, Firedancer is here. And as a bonus, this has opened the door to a multi-client future. As diversity grows further, the network becomes less and less affected by a bug in any single client, like this. For example, if multi-client is future, what if a bug hits the Agave lineage? No problem. Firedancer, no problem. Okay, it's a multi-client future. And next, let's look at Firedancer and Firedancer here. And Firedancer. As you can see here, Firedancer is a hybrid model that was built to bridge the migration to Firedancer. As you can see here, part of it still uses Agave in Firedancer. By the way, both Firedancer and Firedancer uses this tile architecture. And the work is split into units called tiles, and each tile gets its own dedicated CPU. And you can tap any tile to see what it actually does. Feel free to explore, like net, quick, verify, deduct, and so on. And notice that in the full Firedancer is here. Full Firedancer. Every tile has been replaced with Firedancer native implementation. It's good. Okay, then next let's try the bottleneck simulator pipeline. Good, this one. Oh, stop. Okay. What happens if 100,000 transactions per second pour in? But there's only one signature verification tile. And keep in mind, signature verification is a time-consuming process. This one. The answer is it becomes a bottleneck and transactions overflows. This one. Oh, bottleneck happens and drop happens. As you can see, lots of transactions are overflowing and a bottleneck has formed. So what should we do? The answer is just add more verified tiles. Let's add them now. Now its verified tile is 1 and 25 and 2. Oh, speed up. Speed up. 3, 4, 5. Oh, good. And this bottleneck is gone, and bank is now 1. So next, add 2, 3, and now it's a bottleneck, but 3, 4. Oh, okay. Now a bottleneck is gone. So by assigning multiple CPU cores to verify, the bottleneck gets resolved. And by allocating core precisely where the work is heaviest, Firedancer unlocks a much higher performance. And next, let's look at the kernel bypass. What we just saw was the flow after a transaction enters the validator. But if it takes too long just to reach Firedancer in the first place, the overall speed cannot improve. That's why Firedancer uses a technology called AFXDP to bypass the kernel. This one, Firedancer AFXDP. And this speeds up the journey to the validator itself. Let's try it. Wow, too fast. Good. If you want to learn about each step, just tap the tab. For example, driver, kernelnet, socket buff, and so on, and XDP hook. Also, everything we've seen so far is what happens when the validator is a reader. Net quick verify and so on. This is this one. Okay. And here is what it does the rest of the time. Which it is actually most of the time. Shred, store, replay, and consensus, and send both. And of course, there are processes like gossip and repair and so on that run continuously. And next, let's also talk about speed part. In lab benchmarks, Firedancer has already hit 1.1 million TPS. Now let's look at the actual mainnet. We are not at 1.1 million TPS today, but there is huge headroom ahead. First, as faster clients spread, they can pack more transactions into each block when it's their run as reader, so effective speed gradually rises. Then, once first client exceeds 2/3 of stake, the protocol limits can be safely raised, and the whole network steps up a gear, like this. Like this. Good. Too fast. Oh, sorry. Too fast. Great. But slower validators fall behind for a moment. But they catch up afterwards. And on top of that, a protocol upgrade called Alpenglow is set to dramatically shorten transaction finality to around 150 milliseconds. Like this. Speed up. And note that the multiplier number in the demo are just examples to illustrate the mechanism. And finally, let's look back at the journey so far. Development started in 2022, and in December 25, it was announced that Firedancer was live on mainnet. Then, live in May 2026, it reaches Firedancer 1.0, and now it's expanding toward a majority stake adoption. So, what did you think? That wraps up my explanation on Firedancer. The demo link is in the YouTube description, so give it a spin. Thank you so much for watching until the end. Thank you. Bye bye.